What if quantum physics could change space travel forever? Tunneling for engines, entanglement for secure comms, and zero-point energy for endless power. These ideas are bold, real at small scales, and being tested today. The future might start now. How quantum mechanics could revolutionize space travel. Imagine a wall, solid, impenetrable. You can't go through it, you can't go over it, you are stuck. But what if I told you there's a way? A way to simply appear on the other side, without ever breaking the wall down. This isn't magic. It's a whisper from the deepest, most bizarre level of reality. It's a secret the universe has been keeping, hidden in the strange and wonderful rules of the quantum world. This is the world of the very, very small. Particles behave like ghosts, existing in multiple places at once and performing feats that defy everyday logic. This ghostly realm holds the key to unlocking humanity's future among the stars. We stand at a precipice, looking out at the vast cosmic ocean. For generations we've relied on brute force to explore it. We burn massive amounts of chemical fuel, strapping ourselves to controlled explosions to escape gravity. It's ingenious but slow, inefficient, and incredibly expensive. The stars, like distant, glittering islands, remain out of reach. But physics, the same science that described the fall of an apple and the orbit of the moon, is revealing a new path. A path that doesn't rely on bigger rockets but on smarter physics. The revolution won't be televised, it will be quantized. The journey begins by accepting a new kind of reality. At the scale of atoms and electrons, the universe plays by a different set of rules. Particles are not solid little balls, they are fuzzy clouds of probability. They can be in many places at once until we look at them. They can borrow energy from nothing. They can be connected across vast distances instantly. For a long time we thought these effects were philosophical oddities confined to the lab. Now we're on the verge of harnessing these powers, turning curiosities into engines for exploration. Let's go back to that wall. In our world, if you throw a ball at it, it will bounce back, every single time. But in the quantum world, things are different. If that ball were an electron, there's a tiny but real chance that it could simply vanish from one side of the wall and reappear on the other. It doesn't break the wall, it doesn't blast a hole through it, it just tunnels through. This is called quantum tunneling. It happens because the particle's location isn't a fixed point, but a wave of probability. Part of that wave can leak through an energy barrier like the wall, allowing the particle to cross an impassable divide. This isn't just a party trick for tiny particles, it's the reason our own sun shines. The core of the sun is hot, but it's not quite hot enough for hydrogen nuclei to overcome their natural repulsion and fuse together based on classical physics alone. They just don't have enough energy to climb that repulsion wall. So how does fusion happen? They cheat. They use quantum tunneling. The nuclei get close and then, thanks to the weirdness of quantum mechanics, one tunnels through the barrier of the other, allowing them to fuse and release a tremendous amount of energy. The light and warmth you feel on your skin right now exist because of this quantum leap. So, how does this help us get to the stars? By building our own miniature suns. Scientists are working on fusion reactors that could power the starships of the future. These engines would be incredibly efficient, turning a small amount of fuel like hydrogen into immense energy. A fusion-powered spacecraft could accelerate continuously, reaching speeds that would make a trip to Mars feel like a weekend getaway. It could shorten a journey to the nearest star system, Proxima Centauri, from tens of thousands of years to a mere human lifetime. We would be harnessing the same quantum trick that powers the stars to travel among them. The challenges are still enormous, of course. Containing a star within a magnetic bottle is one of the hardest engineering problems humanity has ever faced. We need to sustain the fusion reaction long enough for it to be useful, and we need to make the reactors small and light enough for a spaceship. But the principle is sound, proven by every star in the night sky. We are not trying to invent new physics, we are simply learning to apply the physics that the universe has been using for billions of years. The path to interstellar travel might just be paved by tunneling through the impossible. Now for something that even made Albert Einstein uneasy. He called it spooky action at a distance. Imagine you have two coins that are magically linked. No matter how far apart they are, one in your hand, the other on the moon, if you look at yours and its heads, you know instantly that the other one is tails. This is the essence of quantum entanglement. When two particles are entangled, they become part of a single quantum system. Measuring a property of one particle like its spin instantly influences the corresponding property of the other, regardless of the distance separating them. It's as if they are communicating faster than the speed of light. Let's be very clear. This spooky action cannot be used to send information faster than light. You can't control the outcome of your measurement. You might get heads, you might get tails. You won't know until you look, so you can't send a Morse code message to your friend on the moon this way. However, you can use it to create a perfectly secure communication channel. If an astronaut on Mars and a controller on Earth share a stream of entangled particles, they can create a secret key for encrypting messages. Any eavesdropper who tries to intercept and measure the particles would instantly break the entanglement, and the change would be noticed immediately. Think about what this means for space exploration. Sending a command to a rover on Mars can take up to 20 minutes one way. The delay is frustrating for scientists and dangerous for robotic or human missions. A single bit of corrupted data could be catastrophic. With quantum communication, messages would still travel at the speed of light, but their security would be absolute, guaranteed by the laws of physics. Mission data, scientific discoveries, and even personal messages from astronauts could be sent across the solar system without any fear of interception or tampering. It creates a truly private line across the cosmos. Scientists have already demonstrated this. They have teleported the quantum state of a particle from the ground to a satellite in orbit, proving that entanglement holds over vast distances. The next step is to build a network of satellites, a quantum internet, that could relay these entangled signals across the solar system. It would be an invisible web of secure connections linking Earth to our future outposts on the Moon, Mars, and beyond. What if you could power a starship with nothing? What if the empty space between the stars was itself a limitless reservoir of energy? This isn't science fiction, it's actually a profound prediction of quantum field theory. The vacuum of space, what we once thought of as perfect emptiness, is actually a bubbling, frothing sea of energy. It's filled with virtual particles that pop into existence and then annihilate each other in timescales just way too short to measure directly. This seething energy, present everywhere in the universe, is called zero-point energy. It's the lowest possible energy that a system can have, kind of like the baseline hum of the cosmos. The amount of this energy is honestly staggering. According to theory, the zero-point energy contained within a single light bulb's volume is enough to boil all the oceans on Earth. It's the ultimate clean, renewable energy source woven right into the very fabric of space-time. If we could figure out how to tap into even a tiny fraction of it, our energy problems would be over forever. For space travel, it would be the ultimate game-changer. A ship powered by zero-point energy wouldn't need to carry any fuel. Its fuel tank would be the universe itself. It could accelerate for as long as it wanted, potentially reaching near-light speeds. So, how might we extract this energy? Well, one theoretical concept is the Casimir effect. If you place two uncharged metal plates very close together in a vacuum, they are pushed together by an unseen force. The reason? There are fewer virtual particles popping into existence in the tiny space between the plates than in the open space outside them. This imbalance in the zero-point energy creates a pressure that pushes the plates inward. This effect has actually been measured in the lab. It's real. Some researchers theorize that we could build engines with oscillating microcavities that could extract usable energy from this effect. Of course, this is where we venture furthest into the frontier of known physics. Extracting net energy from the vacuum is a monumental challenge. Many proposed devices violate the laws of thermodynamics and, well, no one has successfully built a machine that produces more energy than it consumes. Some physicists believe it may be fundamentally impossible, but the energy is there. The universe has confirmed its existence. The question is not whether the treasure exists, but whether we can find the key to unlock it. If we can, the concept of a fuel gauge will become a relic of the past, and our ships will drink directly from the ocean of cosmic energy. The journey from a wild idea to a working technology is long and arduous. The promises of quantum mechanics, fusion engines powered by tunneling unbreakable communication through entanglement, limitless energy from the vacuum are not guarantees. These phenomena are delicate and elusive, incredibly difficult to control on a large scale. Maintaining quantum coherence, keeping entangled particles linked, extracting energy from the vacuum are challenges that push our scientific and engineering limits. We are still in the dawn of this quantum age, taking our first steps in a strange new landscape. But every great leap began as an impossible dream. People once scoffed at flying machines, scoffed at splitting the atom, scoffed at walking on the moon. The limitations of one generation often become the triumphs of the next. Labs around the world are laying the foundation for a future we can barely imagine. Successful entanglement experiment, small step towards sustained fusion. New insight into the nature of the vacuum bring us closer to that future. The path is not easy, but the destination, a true starfaring humanity, is worth the struggle. Imagine a trip to an extrasolar planet as a grand, achievable expedition. A ship silently accelerates. Its fusion core, a miniature star, burns bright thanks to quantum tunneling. Crew communicates with Earth instantly and securely through entangled particles. The ship sips energy from the space-time it travels through. This is the vision. Quantum-powered exploration. We explore not with brute force but with elegance and wisdom from deeper understanding. The universe is under no obligation to make sense to us, yet it has given us clues, whispers of a deeper reality we are starting to decipher. The story of our species is looking up and wondering. Now we are on the verge of not just wondering but going. If this sparked your curiosity, join our voyage. Subscribe to our Universal Universe channel for daily cosmic adventures, and don't forget to share and like the video. Keep looking up. The future is quantum.